right, here we are, part B, example 3. Speed of current in a body of water is 1.5 kilometers per hour. So there's an extra H there, sorry. So let's think about this first. I've got speed of a current, so it's flowing this way, 1.5 kilometers per hour. So when I swim with the current, I get faster, and swimming against the current, I get slower. So how fast can Erin swim in still water? I'm going to let that be my x. So with the current, is Erin's speed is x plus 1.5. So Erin's speed with the current, x minus 1.5 is Erin's speed without the current. And he swims for a distance of 3 kilometers. So he goes 3 kilometers this way, turns around and comes back. Total time, 2 2/3 hours. So let's think about how we're going to get time. We know distance is equal to rate times time. Well, that means, of course, that time is equal to distance divided by rate. So going against the current, we don't know how long that takes him, but we know he goes for 3 kilometers at a speed of x minus 1.5. So this is his time going against the current. So time against current. And then if we add 3 over x plus 1.5, this is his time with the current. And that's equal to his total time, which was 2 2/3 hours. So now I've got an equation to solve. I'm going to start by making this all fractions. So 3 over x minus 3/2 plus 3 over x plus 3/2 equals 6/8. I see, just looking at all these fractions, I don't want to look at them, so I see a least common multiple of 6, and I'm not even thinking of the full denominator here. I'm really just thinking of the 2 and the 3 over here. So I'm going to multiply top bottom by 6, 18 over 6x minus 9 plus 18 over 6x plus 9 equals 16. Now, these I could, of course, simplify. I could factor out a 3 from each of those. So factoring out the 3, in which case, actually, I didn't need to do this least common multiple. I could have just simplified both sides. So, sorry, I'm going to go back and simplify both sides. So I'm not going to look at a least common multiple yet. I'm going to multiply top bottom by 3 on this side, top bottom by 2 on this side. It's a much smarter way to do it. So 6 over 2x minus 3, 6 over 2x plus 3 equals, multiply. Here I can't do anything. I can't multiply top bottom by 2 because that's still, or by 3 because that still leaves me fractions. So I've still got 8/3, but at least I got rid of the fraction in the fraction here. Set up my common denominator. These together are going to make 4x squared minus 9. And I have a 3 also. So least common multiple, 3 times 2x minus 3 times 2x plus 3. That's the same as 3 times 4x squared minus 9, because those are differences of squares. All right, so making my least common multiple, 6 times 3 times 2x plus 3 plus 6 times 3 times 2x minus 3 equals 8. It already has the 3, so I'm missing these two, and those two together are 4x squared minus 9. And once I have my least common multiple, I'm ignoring the denominators, knowing, of course, that x is not allowed to be 3 over 2. And that I could have seen from my very beginning. All right, solving. 6 times 3 is 18, times 2, 36x, 54, 36x minus 54, 32x squared minus 72. Cancel, cancel. And 32x squared minus 72x minus 72 equals 0. All of these divide by 8. 4x squared minus 9x minus 9 equals 0. I don't think this factors. Sum of negative 9x, product of negative 36x squared. Oh, it does. 12x, negative 12x plus 3x. So 4x times minus 3. That'll be a single x. That'll be a plus 3. So 4 times negative 3 gives me my negative 12. 3 times x gives me my positive 3x equals 0. X is negative 3/4, or x is 3. If I go back to what x originally stood for, x stands for Aaron's speed in still water. So in still water, he has to have a positive speed. This is an invalid solution. So Aaron's speed in still water is 3 kilometers per hour. And there you go. Hopefully that wasn't too confusing. And if it was, let's talk about it in class.